Hello everybody. Okay, so today we're going to go over section 5.2, dividing polynomials. The first one we're going to do, we're actually going to learn three different things about dividing polynomials. This first one is dividing with monomials, so it's going to be easier than the other two methods. So what makes a monomial is when you don't have any addition or subtraction involved. It's all multiplication. So this denominator, that is a monomial. The numerator is not a monomial because you have addition and subtraction involved in the terms in between. But this denominator is only one term. So what I can do, since I just have the one term in the denominator, is I can break the numerator up into actually three fractions and then simplify. I can put each term of the polynomial in the numerator over the denominator. Okay, and then I can just simplify each one individually, and that will be my solution. That'll be my answer. Okay, so this first term, the 4's are going to reduce out. X to the third divided by x is x squared. Y squared divided by y is y. My middle fraction, 8 divided by 4 is 2. X is reduced out. Y squared divided by y is y. And my last fraction, 12 divided by 4 is 3. X squared divided by x is x. Y to the third divided by y is y squared. And that is going to be the final answer. It's all simplified. The next division problem we're going to use is number 2, when I am dividing by a binomial. Okay, so this division method that I'm going to show you is called long division. So that's z squared plus 2z minus 24 divided by z minus 4. So what I'm going to do is I'm going to set this problem up and using a division symbol, just like you did when you were in grade school. And I am going to divide these two using a method similar to what you all did in grade school. Okay, so the way that you start is you're going to take this first term that you're dividing by and divide it into the first term of the polynomial inside your division sign. So I'm going to do it out here to the side so you can see what I'm doing. Z squared and divide by z. So when I write it like this, you can see that that's going to simplify to be z. So z squared divided by z is z. And I'm going to put that term right above the z squared that I'm dividing into. Okay, so the second step is I'm going to multiply this back into the binomial. So z times z is going to be z squared. I'm going to write the product right underneath what I'm dividing by, or dividing into. Z times negative 4 is minus 4z. Okay, so I'm going to subtract that product from the terms above it. And every time I do that, the first terms should subtract out. So that's going to be 0. Then you have positive 2z minus a negative 4z. That's 6z. Bring down your next term like you do when you're dividing numbers in long division. And then we're going to do the whole thing over again. So z is going to go into 6z. I can write it out here so you can see. Got a positive 6z divided by a positive z is 6. So that means I'm going to add 6 in the quotient. So 6 times z is 6z. Now I'm multiplying back through again like I did before. 6 times negative 4 is minus 24. I'm going to put parentheses around that product and subtract it from the binomial above it. 6z minus 6z, that's 0. Negative 24 minus the negative 24, that's 0. So you don't have anything left over. There's nothing left to bring down. You don't have anything else to divide. So your answer, your quotient, is z plus 6. That is your answer. That's what you get when you divide z squared plus 2z minus 24 by z minus 4. Okay, I'm going to do one more example of long division. I'm going to work number 8. So I'm going to set it up with x minus 2 outside the division symbol, 5x to the third minus 13x squared plus 10x minus 8 is inside. Okay, so we're going to start out by taking the first term that you're dividing by, divide into the 5x to the 3. So I'm going to write that out to the side so you can see what it looks like as a fraction, and that would simplify to 5x squared. Okay, so 5x squared goes above that term, and I'm going to multiply that back through the binomial. So I'm going to have 5x to the third minus 10x squared, and I'm going to subtract that. So your first term should always add to be a 0. If that doesn't add out, then something's wrong. You need to look at it again. But this should always be a 0. Then negative 13x squared minus a negative 10x squared is going to be negative 3x squared, and bring down the next term. So if I have a binomial outside that I'm dividing by, then I should have a binomial that I'm going to divide into. I only divide into these first two terms to start it, so now I'm just going to divide into these first two terms. Okay, so take your x, divide into negative 3x squared, so I'm going to write it out here to the side so you can see what it looks like, and I'm going to have a negative 3x for a quotient, so I'm going to write that above the middle term, or I'm sorry, it's not the middle term, it's the negative 13x squared, because there's 4 terms. So then I need to multiply this back through the binomial. So I'm going to have a negative 3x squared plus 6x, and that's going to be subtracted. So again, the first term adds to be a 0, which is the way that it always should be. 10x minus 6x is 4x, and I'm going to bring down the next term, minus 8. And let's do it all over again. So x goes into 4x 4 times. So I have a plus 4 that I put above the division bar, and I'm going to multiply that back through the binomial outside here. So 4 times x is 4x, and 4 times negative 2 is negative 8. And when I subtract that, they both subtract to be 0. So I don't have a remainder, and my quotient is 5x squared minus 3x plus 4. So notice my quotient, the leading variable, the degree is always 1 less than what you're dividing into. So you should always have at least 1 less that you're dividing into. And that's all of long division that I'm going to do right now. We'll do another example tomorrow during class. Make sure and write down any questions you have. And so let's take a break, and then we're going to come back, and I will show you another method of division that you might like a little bit better. So come back in a few minutes. See you then.